time graph. Velocity and as well as the time graph. Which one is called velocity and as well as the time graph, and how it will be as performs. Actually, we are taken what it is velocity at a where velocity at here on which axis we are taken it is on y-axis, and as well as time is on x-axis. Time is we are taken on x-axis. That is the called what velocity and as well as the time graph. Got it or not? I hope you got it here. As now there is a what we are considered here on this axis, there is a time variation. In case you are taking here velocity on this particular graph, okay, it will be produce the information about the body which is a uniform motion or not, uniform velocity or not. It is a content, and as well as there it is in case the constant velocity is there or not. Yes, understood or not, all the students? The body is it in a rest or not? Okay, clear or not? These all the information we are considered here. Got it or not? Yes, and here the first thing is the velocity is in uniform motion. Nothing but there is a change of the velocity is the same here. Okay, a point to point. Suppose 1 second, 2 second, 3 second, 4 second, 5 second, 6 second. Okay, like that we are considered. In this particular situation, same as like that, it will be taken in this particular form. What happened here? Suppose it is a 2, it is a 4, it is a 6, it is a 8, 10, 12. Okay, now, yes, the points, how will we get the straight line? The points are in this particular mode, we'll get the straight lines. Got it or not? And the third one, it is here, and the fourth one, it is here. Okay, clear or not? Fourth one, somewhat here. Okay. For fifth one, it is a 10 seconds. Like that, everywhere I am taken a 2 meter per second velocity is a contain. Okay, now here also 2 meter per second, here also 2 meter per second. Like that, it will be there. Now it is a called what? It is a called uniform velocity only. Got it or not? It is a called uniform velocity. I hope you got it here. Uniform velocity, and here what we get here from this particular curve, slope of this curve is gives the information about the acceleration. How it will be given the acceleration? 1 second. Here I am taken the point here A, and here I am taken the point B here. Got it or not? It is what we are I am considered here. There is it is a second, and it is a container 4 meters per second velocity. At a B, at a fourth second, it is a contain 8 meters per second velocity. Okay, how will get the acceleration now? The acceleration or slope. Slope is equal to taken as what here? Y2 minus y1 by x2 minus x1. Here, what is the y2 here? There is the 2 points are there. One is the 2, 4, another one is the 4, 8. It is x1, it is the y1, it is x2, it is the y2. And here, there is a 8 minus 4 by 4 minus 2. Okay, got it or not? It is a 4 by 2. It is written as 2 meters per second square. This is in this way, it is a produced the what? Acceleration. Okay, got it or not? It is a called acceleration, change of rate of velocity. It is a what actually velocity changes. It is a what time changes. The del V by del T is only called as what? Velocity. Okay, clear or not? Velocity change for a time. That is only called what? That is called as acceleration. That is called what? Acceleration. This is about the VT graph, students. Once we go through our textbook, the page number 71. Different graph they given a conclusions about that. Yeah, there is a word they given. First, there is graph A, page number 70. First one, take it. When velocity graph contain a uniform velocity here. Okay, clear or not? One second. There is given what here? There is a one graph is given like this. Yeah. What we are considered here, there it is the first second, it is the second second, it is the third second, it is the fourth second, like that it is the fifth second we are considered. Now, there is on a first second, it is a container 20 meters here. Suppose what they consider on this one, they consider for every 5 meters they taken one, okay, as a particular displacement velocity change they are considered. This is a 5, this is a 10, this is a 15, this is a 20. What is this? This is the velocity. This is a what? This is the time we are considering. Got it or not? And here, every time there is a for a first second, for a second second, for a third second, for a fourth second, for a fifth second. Every time it is a container what? On this particular point, there it is a 20 meter per second velocity only. At this particular point also it is a contain 20 meter per second velocity. At this particular point also it is a contain 20 meter per second velocity only. Here also 20 meters per second velocity only. Here also 20 meters per second velocity only. Everywhere there is a 20 meters per second velocity only there. Okay, what you understood from this one? For equal time interval, equally it will contain traveling. Got it or not? And there is no change in the velocity. Okay, throughout its path it is a contain a same velocity. That's why it is a called uniform velocity. The body not it is in rest here. The same diagram, in case you are not observed properly, like this it will be there. Suppose it is a displacement, it is in a meters, it is in a time. The body it is in now rest condition. It is in a rest condition. But the same thing, the graph look like a same. But there is what it is, velocity and time graph. Now the body is not in a rest here. Okay, clear or not? Yes, it is a what? It is in a rest condition. Got it or not? It is a rest condition. It is in under motion. Got it or not? Now why? Because it is under motion. It is a contain already velocity, but uniform velocity. No change in a velocity. Got it or not? Every time it is the first second, second second, third second, and whatever the path it will be contained along it, it will be contained same velocity. Such a type of the bodies are called uniform velocity body. Okay, clear or not? Suppose it is not 20 somewhat, it is a 20 somewhere, 30 somewhere, 10 somewhere. It is a called what? Non-uniform velocity. Got it or not? This is only about the uniform velocity graph. And so other graphs, so many other graphs are given here. Yeah, it is the what? It is a uniform velocity. The graph is representing uniform velocity. And this is also given for us what is the displacement made by it. How do we find out the what is the displacement made by it? Yeah, when you draw that is one rectangle or whatever the area covered as below this curve. Okay, clear or not all the students? Whatever the area covered below this curve is only called displacement made by it. Okay, clear or not? Yeah, one second. What is the area? How to find out? It is a rectangle. Area of rectangle is taken as length into breadth. Okay, now here area is equal to somewhat they taken a P, Q, R, and as well as the S. Now the area become what now? The area become PS into S PR, or otherwise PS into S PR or PS into SR. Okay, clear or not? Yes. Not PR, PQ. PS into PQ. Got it or not? What is the PS here? Then it is taken as a 5. Okay, what is the PQ here? 20. Okay, now what it become? 10 meters and 100 meters. The body traveled in this particular condition. How much distance? How much displacement? 100 meters. Okay, clear or not all the students? From the velocity, you'll get the what actually from the velocity and time graph, we get how much displacement made by the body also. Okay, got it or not? The displacement made by the body in this particular time is given by this velocity and time graph. Okay, clear or not? The area which is contained below the curve is only provide the displacement. Understood all of you? Yes, generally we consider our formula. V is equal to distance by time or displacement by time. Displacement is equal to velocity into time. 1 second, this is a velocity or not? This is a time or not? Okay, got it or not? Yeah, 1 second, there is a displacement getting this particular way. Okay, yes, and this area it is equal to what? It is equal to displacement. Yes, whatever the graph contain V by T under the area of the curve is a provide for what? Displacement of the body which is made with the uniform velocity. Got it? Yeah, this is about a concept of our uniform velocity. Please note down the graph and as well as please note down this is a graph which is represent uniform velocity and that is indicates the what displacement. The area it is equal to PSQR. The area yes, EQSR area. Yeah, next component. The same VT graph only here we consider, but the VT graph, it is not a parallel to the x-axis. Okay, another VT graph that it is be taken as B. Okay, now like this, it is represent already we are discussed. What we are discussed? There is a change of velocity in uniform rate. Okay, clear or not? There is a what we are consider. There is it is the first second. It is the second second. It is the third second. It is a fourth second. Got it or not? One second. There is everywhere. Okay, clear or not, all the students? Everywhere there is zero. It is 0 to 1 second. Suppose 2 meters, 4 meters. Okay, now 6 meters, 8 meters. Okay, this type of variation in a velocity is called change of velocity. Yes, there is a velocity is not a constant. Before in the diagram, velocity is a constant. Okay, now everywhere the velocity is the same. Okay, now velocity is not a constant. It is a change with the time. Okay, clear or not? It is a change with the what? Time. Change of velocity with the time. Change of velocity with what? With the time here. Got it or not? Yes, T and as well as this is the displacement made by. Got it or not? I hope you got it here. Yes, and it is a 1 comma, yes, a 2. It is a 2 comma 4. It is a 6 comma, sorry, 3 comma 6. It is a, yes, so 4 comma 8 we are considering. Yes, from this one, so many informations are may get for us. Okay, already we are discussed. What is that? What is that? Acceleration. Acceleration will get directly by slope. Okay, clear or not? Yes, and as well as one more information also will get from this one. That is about displacement. Yeah, how do we get the displacement for it? Same, but here we are consider triangle. Okay, not totally. What will we get? Triangle. Everywhere we'll get the triangle here. Okay, suppose I am taken overall purpose. Okay, total here, this is the one triangle will be get. Suppose I am the area of triangle is a provide for us what? The area of triangle is a provide for us. Okay, now what it will be provide? Area of triangle. Okay, now it is what actually half into breadth into height. This is only called area of triangle. Here, what it is become now? Base is nothing but OB. Height is nothing but BA. Okay, got it or not? Half into, yes, OB into S. What it is? BA. This is equal to what here? It is equal to, yes, displacement made by the body. From here also, you get the displacement in this way. Displacement made by the body, it will be given. Okay, suppose here in this particular condition, what is the displacement? It is a 4 half into 4 into what is the 8. Okay, now it is what? 8. Okay, now yes, it will become what? A 16 meter displacement made by this body. In this way, we are considered from the graph. Got it or not? When they given a velocity and as well as the time graph, there is a two informations are get for us when it is in a change of velocity with the time. Okay, now with the time here, there is a two informations are get. One is acceleration, another one is a displacement. Acceleration simply defined by, okay, acceleration is equal to taken as what? Acceleration is equal to taken as what we are considering here. Acceleration is equal to what we are considering? Slope. Okay, it is equal to slope of line. Slope is equal to y2 minus y1 by x2 minus x1. Any between any 2 points. Okay, now you consider it is either from 0 to the 4 also. Okay, na 0th seconds to the 4th second also may we have to find. Okay, got it or not? Yeah, there is a what is the acceleration may get from this particular diagram. Okay, in this way there is, we find out acceleration. In this way we find out the displacement made by. Got it? Yeah, please note down. Yeah, next component. Okay, after this, one more graph is also there. Yeah, taken it as a C. Okay, once check it in that graph, then it will be not start from rest. Yes, how we consider it start from rest? All the graphs are taken from origin and O comma, sorry, 0 comma 0 we are taken here. But here sometimes there is a body cannot start from rest. Okay, it is always come start from rest only, but we not consider it is not from rest. Already the body is a, suppose this body, yes, at this particular position, when there is it is a fall down and taken in this particular height, not in this particular height. Suppose it will be come from this height and consider velocity from this particular point. Okay, otherwise one bus is traveling in front of you. Okay, now it is already started traveling somewhere it is. Okay, now we are not taken from that particular point where you are observed. Okay, now that body only, that position only we are considered here. Okay, clear or not all the students? Yes, and here we are taken it is what? Here we taken it is at this particular point. Okay, already it is a 5 we have, 10, 15 and as well as the 20 like that here we consider. Got it or not? Now there is a body may move afterwards. There is a uniform rate change. Okay, now again uniformly only changes. Yes, at a 1 second it may reaches to the what somewhat here. Yeah, it is the first second. It is the second second. It is the third second. Okay, got it or not? Now there will be body moving like this. Got it or not? Now there is it look like a what? One trapezium is formed here. Got it or not? It is a called what? It is a called as a trapezium. Okay, got it or not? 1 second. The body is not started at 0. It is started at yes. What are the coordinate we have here? 0, 5. Okay, 1, 10, 2, 15. Okay, like that here we consider. Next 3, 20. Like that you consider in this particular situation, you'll get the acceleration and as well as the yes, whatever our displacement. Okay, now the same thing for a displacement or distance traveled by the body. Every time we are taken our what here area only, but here we are consider the what area of trapezium we are consider. What the trapezium is a formed here? The trapezium is a formed as ECAD. Got it or not? It is a formed as a ECAD. Okay, how it is? The point I am taken E and it is a taken C. It is a taken A. It is a taken D. Okay, ECAD trapezium is a formed. Meanwhile, I am taken it is a B. No problem. Got it or not? Now I am taken that is a whatever our acceleration it is there. The acceleration is equal to taken as okay AB by BC. AB by BC. Got it or not? AB by what we are considered BC. The same thing. There is a no change in that. What is the AB indicates here? Y2 minus Y1. Okay. What is the BC indicate here? The BC indicate X2 minus X1. Understood or not, all the students? There is a no change in that. Y X coordinate by the Y coordinates. That's it. Okay. Now difference between X coordinate by the Y coordinates. Next, what we are consider after this? Area of displacement. It is taken as what? Area of displacement. What is area of area is indicate what? Displacement. Area is equal to displacement. What is the area? Trapezium area. What we are considering here? Which is trapezium? EBSCD trapezium. We are considered here. That is what is the trapezium? You know very well it is the one type of a diagonal only. Okay, now yes, now trapezium is equal to taken as what we are how to be consider trapezium area, you know, CE plus AD. CE plus AD into ED. 1 by 2. Got it or not? This is only we are consider as here trapezium. Okay, got it or not? EBCD trapezium it is equal to half into CE plus AD into ED. Got it or not? I hope you got it here. Yes, I hope you got it here. This is only as area of that particular trapezium. Okay, from that one you'll get the what is the displacement made by this particular okay now yes body. Yes, when it starts from rest and as well as it is moving somewhat a uniform change of rate. Okay, clear or not it is? This is only called as okay VT graph for a when it is started a rest and it will be moving with somewhat as uniform change of rate velocity. And the last one take it last one important. This is a regularly we may not get situation. Most of the things are may not get this situation. Yes. Next year. Here the D here last component. Suppose there is a change is occur, not a uniform rate here. Okay, clear or not all the students? Uniform rate it is may not occur. Okay, now every time there is a velocity that changes regularly. Okay, it is not a contain same velocity. Okay, it is a changes its a velocity regularly with the time. Okay, that is only called as here what it is. It is called as what here? Non-uniform change in a velocity. Non-uniform change in a velocity. Okay, now not equally changes are get here. Okay, now how 1 second here it's a start here yes with the 6 here. Okay, in a textbook they given start here what start with the 6 meters distance only. Okay, got it or not? It is a start with the 6. And next year 0, 3, 6, 9, 12 they consider. Okay, got it or not? And here time they taken 0, 2, 4, okay, na 8, 10, 12, and as well as the 40. Like that they consider. For the 0th second, it is a what we are considered here. Sorry. Yeah, for a 0th second, it is at a where 6. And now there it is a second, it is a reaches up to 9 seconds, 9 meter distance. Then again it will be okay, continuing the same pattern here for up to 4th second. It traveled what with the same velocity. Okay, up to where? Up to here it is a travel same velocity, no change in a velocity. Then after it is a gradually decreases 4 to 6 seconds. It will be okay at a 6 seconds. It will be reaches to where on a 6 centimeters only. Here it will be taken here. Okay, na it will be moving like this. Got it or not? Next afterwards again decreasing. Okay, na yes at a 8 second it will be contain only just 3 meters per second velocity is only there here up to. And the next again it is a continued with the somewhat same speed up to 12th second. Okay, clear or not? And then after again it will becomes to rest. Once check it this curve, how it will be looks. Somewhat it is a what? It will be start from where? Here. It will be start from here. It will be moving in a uniform velocity. Okay, suppose I am taking it is a A, B, C, and as well as a D, E, and as well as F point. The totally it will be give the information about the whatever the path followed by the body and what the different types of velocities are there. All the graphs you know whatever we discussed in this graph only make it. Okay, once check it. Here it is start from not rest. Okay, now it already contains somewhat velocity. 6 meters per second velocity is there. From year to year, it will be increasing its velocity. Okay, now then after it will be contain uniform velocity B to C. No change in a velocity in these 2 seconds. Second to 4th second, it is contain which type of velocity? Uniform velocity. It is increasing velocity. Then next decreasing the velocity. Okay, clear or not? How it is decreasing? Uniformly decreasing. For every 2 seconds, 2 meter per second. What here? 3 meter per second velocity decreasing. Then again it will be uniform. Sorry, it is a container what? Uniform motion. Okay, no change in a velocity. Got it or not? Velocity is the same here. Okay, no change in a velocity. Again it will become rest here. Okay, clear or not? At a 14 second, there is a no change in a velocity. It is 0. Where it is in a rest? At the point F, it is in a rest. Here it is not called rest. It is a change in the velocity uniformly. Here also 3 meters per second velocity only. Here also contain 3 meters per second velocity only. In this way, there is a not a change, not a same velocity is there. Okay, velocity not a gradually changes, equally not changes here. Okay, unequal changes are there in a velocity. Got it or not? In this particular situation, okay, acceleration we have to find out from one point to the another point. Okay, by using the slope only, slope of that curve only. But the displacement, how do we find here? Yeah, we calculated yes number of whatever the squares are there. Got it or not? How to find out here? Number of squares into area of one square. Okay, clear or not? Suppose I want to find out there is a whatever the velocity contained from here to here. Okay, how many squares are there here? Okay, now yes, once check it in our textbook. They given what? Okay, it's from particular point where from second to second to the 8th second. Okay, now yes, the square sometimes there is a one square is there in a graph. It is half square only. Okay, our square area become what? 1 centimeter square. Got it or not? Okay, clear or not? In a generally graph, how much area it is the content? 1 centimeter square. But our scale based, there it is a 2 seconds it is given. It is a 3 meters they given. Okay, now based on that one, you have to calculate. May in case it is occupied only half. It is a half only. It become what? Full. Area is a full here. It is only half. Again, it is a half. Like that, we are considered during the problem. When we are go with the problems, we are get the clear clarification on this. How to calculate the displacement made by it? Yes, area of the square into number of square in below the curve. Okay, that is only we are considered. Got it or not? Yes, based on that we calculated all our components. Yes, thank you. This is today class, and this is indicate the what? Non-uniform velocity. This is indicate the what? When the body is not in a rest, it starts from somewhat velocity. Got it? Thank you. Is